Hello, y'all. This is Darrell Lee Berry Jr., still preparing for my exam. That's today, actually. So I'll be doing some review topics for things that'll be on the exam. And if I have time, which I'm sure I will, some problems from the textbook. So let's go ahead and get started. So first thing, theorem 5.3. So assume AX equals B is consistent. And to review the definition of consistent, and it says let U1 be a particular solution to AX equals B. Thus, all solutions to AX equals B are of the form U equals U1 plus B. Oops, plus V, where V solves AX equals 0. So we'll go ahead and prove this. Right? So it says about consistency definition. If a system of equations AX equals B has no solutions, the system is said to be inconsistent. If the system has one plus one or more solutions, consistent. So if there's at least one solution for AX equals B, it is consistent. Simple enough, right? So let's go back to the proof. So the way we can work this is V solves AX equals 0, which means that AV equals 0, and U1 solves AX equals B, such that AU1 equals B. Thus, we can see that all solutions are in this form by saying AU equals AV U1 plus V equals AU1 plus AV equals B plus 0 equals B. Thus, because the solution V vector solves the homogeneous, U1 plus V solves the general as long as U1 solves the general. And that means that U equals U1 plus V solves the general, but not the homogeneous because it'll equal B. Easy enough. And it says page 59 is where that comes from. So let's go to page 59. The part I just read was 55. So these are some propositions. Prop 5.2, distributive property. And there was a scalar property as well, but I don't remember it. At least I remember where it's at. I mean, there's a parent, but I don't remember which page it's on. But I think that's good for now. And you could also go U minus U1. So that'll be the same thing as a U minus U1 equals AU minus AU1 equals B minus B equals 0. So that means U equals U1. It means that this must equal V since it gives the same answer as V. So V equals U minus U1. So U equals V plus U1. Right? That's that one. I'm trying to fit everything on one page. So now we have 2. For what vectors V does AX equal B have a solution? So for what vectors B does AX equal B have a solution? So we don't have any numbers for this one, but we know maybe we'll just do that one in the homework. So I don't have any numbers, so we'll just be making up stuff. Cool. We'll just pick a random. It's not gonna hurt to pick a random. So that's my matrix. And we'll call X equals so 3 by 3. We know this has to be 3 by something. I'll say 3 by 1 since and that would give us a 3 by 1. and I'm going to find B. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 4, 5, 6. So that's going to equal 4, 1, 4, 7 plus 5, 2, 5, 8 plus 6, 3, 6, 9. So that equals 4, 16, 28 plus 10, 25, 40 plus 18, 36, 45. So that's going to equal 32, 77, and 113. And that equals B. So for that vector, is that what they mean? Right. So let's go from parametric to Cartesian. So I'll find a problem in the book. So this would be about the constraint equation. Right? So what I'll do is I'll go ahead and go to page 62. Um, problem B, since it has the answer 3B. So we have A equals 1, 1, 1, negative 1, 1, 2, 1, 3, 4. And we want the constraint equations that B must satisfy. This will actually give us the uh, Cartesian equation for this system. So in a sense, we can say this is a plane 1, negative 1, 1 plus U. Well, no, not exactly, because then it'll add to the other side. Maybe I'll do one like that though. So we need the constraint equation. So I'll say B1, B2, B3. And what I need to do to find the constraint equation, get 1 plus rows of matrix to equal 0. And yes, the row is capital letter. So you want that row to equal 0. So I'll say R1 plus R2, R1, R3 plus R2 is R3. So what I have is plus that 2, 3, and B1 plus B2, negative 1, 1, 2, B2. Then we have 0, 4, 6, B3. So what I'll do, be pretty convenient to say R3 minus 2R1 to R3. So that'll be 0, 2, 3, negative 1, 1, 2, and minus 2R1, 0, 0, 0, and B1 plus B2, B2. So B3 minus 2B1 minus 2B2. All right, so looks like I have a constraint equation. And notice that I don't have to um, necessarily get it in reduced echelon or anything. I just need to get a row equal to 0. And looks like I won't be able to get the top row to 0, so that must be the constraint equation. So the constraint equation is B3 minus 2B2 minus 2B1 equals 0. Or I can say there's a plane x3 minus 2x2 minus x1, 2x1 equals 0. That's my constraint equation. So let's go to 1.5, number 3b, and check the answer. And of course, the book changes the signs of everything. So we do have equals 0. We have 2x1 or 2b1. Now I have a 2 for my b. You have a 1. So, oh, okay. They have uh theirs are slightly different, but I know that there can be different constraint equations. So either one of my terms is off, or we just went about it a different way and got a slightly different constraint equation. But that is the process. So I won't linger on that one. I'll move on. Multiply matrices 4 different ways. Let's go ahead and do that. So I shall find, actually, I'll type in a matrix. right? So this is a matrix I wrote out, two matrices that is. I have 5, 6, 4, 1, 8, 6, 2, 7, 8 times 1, 6, 1, 1, 2, 5, 8, 1, 2, and that's A equals B, or A times B. So I'll do it the first way, dot product. So that's going to basically be I take the top row, 5, 6, 4, as it is. And I take the first column as it is. And I'll do the same thing for the second. For that. But this will be the same. And then I go 2, 7, 8, 1, 1, 8. I'm trying to do this a slightly different way. So then I'll try 5, 6, 4, 6, 2, 1, and 1, 8, 6, 6, 2, 1, and 2, 7, 8, 6, 2, 1. And then for the last one, 5, 6, 4, 8, 1, 2, and 1, 8, 6, 6, oh, 8, 1. Did I move? I think I skipped numbers. 1, 5, 2, 1, 5, 2, and 2, 7, 8, 1, 5, 2, right? Now I'm going to write this out how I normally write it. I'm trying to do it a different way. Right, so it looks like I mixed up my what's we call them? I want it to be fancy, but it's actually this row down. Saw that because when I went to think about the dot product way, like directly, instead of the fancy way, the professor wants us to sort of start doing a fancy way. I remember it'll be 5. So basically it'll be 5, 6, 4, dot product 1, 1, 8. And it'll go all the way down the line. 1, 8, 6, dot product 1, 1, 8, and 2, 7, 8, dot product 118. So even trying to do it the fancy way, I mixed up my column numbers. Let me fix that. Even though I looked at a way online where it's just all mixed up seemingly compared to how I normally do it. So that way might work as well. I do want to make sure that I get the sort of same process that I'm used to, but doing the fancy way. 564 dot product 6621 186 dot product 621 and 278 dot product 621. And then we have 564 dot product 152 and 1186 dot product 152 and finally 278 dot product 152. So that's the one I'm most familiar with. And that should give us the right answer there. So what I have is this row, at least this column, dot product the whole row down, and that's the whole row down here, dot product by that. And then we do the same thing with this column, dot product the whole row down, and then this one, dot product everything down, right? So then put that into the normal dot product form I'm used to seeing. That looks right. And then we have 5 times 6 times, 5 plus 6 plus 32, and 1 plus 8 plus 48, and 2 plus 7 plus 64. Notice this will be a 3 by 3 matrix as it should be. And we have 30 plus 12 plus, what's that, 4. And we have 6 plus 16 plus 6, and 12 plus 14 plus 8, and 5 plus 30 plus 8, and 1 plus 40 plus 12, and 2 plus 35 plus 16. So that equals 43, 46, 43, 57, 28, 53, 73, 34, and 48. Let's see if I made a mistake anywhere. Right? So the calculator says 43, 46, 43, 57, 28, 53, 73, 34, and I messed up on the last one, the 48. So what did I do there? 35, 36, 37, 47, 39, 51, 52, 53. Yep, it's 53. So I added that one too hastily, but On the exam, I'll be more careful, but right now I'm just sort of going through the process. So we have 43, 46, 43, 57, 28, 53, and 73, 34, 53. So to make sure I'm clear, I guess this is the fancy way that um, linear algebra wants us to use. Where basically we're taking the row of the column and dot product in all the rows by that single column, by the left column. And now that's your new left column. So I guess you can say these columns in the second matrix, each dot products to make a column in the new matrix. So this makes the first column, this makes the second column, this makes the third column. So you have to dot product that column by the whole matrix to make each row of the new column. And then when I write it out in the normal way, it's like this, where in the vector form, this is basically a vector transpose, and this is a vector. And you dot product that, and each dot product, of course, becomes a scalar, and thus I have my matrix. So another method would be um, linear combination, linear combo. So I've also copied this down. The linear combo method says I'm going to make literally a linear combination of all the different vectors. So I have so I'm going to think about the linear combination way. I should be able to go 1, 5, 1, 2 plus 1, 6, 8, 7 plus 8, 4, 6, 8. And that would be my left column. And then 6, 5, 1, 2 plus 2, 6, 8, 7 plus 1, 4, 6, 8. And then the last one, the last column would be 1, 5, 1, 2 plus 5, 6, 8, 7 plus 2, 4, 6, 8. So now each of these will become a column of the new matrix. So that should be 5 plus 6 plus 32, 1 plus 8 plus 48, 2 plus 7 plus 64. Then the next column, 30 plus 12 plus 4, 6 plus 16 plus 6, 12 plus 14 plus 8. And then we have 5 plus 30 plus 8, and 1 plus 40 plus 12, and 2 plus 35 plus 16. So let's see if this is correct. We have 38, 9, 41, 43. So that was right. So we're looking good so far. 42, 46. That's right. And 38, 39, 40, 41, 42, 43. That's right. So we have 48, 57, 28, 53. And then we have 73, 36, and 53. So let's check that. 43, 46, 43, 57, 28, 53, 73, 34. So I added that wrong. 6, 26. Yep, 34. But on the exam, I'll be more careful with my math. 26, 34, and then 53. So that's correct. So that's the second way. So another way is a linear combination of rows. So this is linear combination of columns, columns of A. And we could do a linear combination of rows of B. All right, see if I can remember this one. Linear oh, okay, I see. So it'll be 5, 1, 6, 6, 1. Oh, hold up. Let me fix my share. All right. So to continue, it'll be 5, 1, 6, 1 plus 6, 1, 6, 1 plus 4, 1, 6, 1. So that must be the first row. Then we have 1, 1, 2, 5 plus 8, 1, 2, 5 plus 6, 1, 2, 5 and 2, 8, 1, 2 plus 7, 8, 1, 2 plus 8, 8, 1, 2. All right. So that's going to be 5, 6, 1 plus 6, 36, 1 plus 4, 24, 1. And then we have 1, 2, 5 plus 8, 16, 40 plus 6, 12, 30. And then we have 16, 2, 4 plus 56, 7, 14 plus 64, 8, 16. All right, so that should equal, I'm going to add all the way across. So these are all basically row vectors, like so. So we have like I did something wrong. Let's see what I did wrong. All right, so I think I'm doing a linear combo with rows incorrectly. Let's see here. Oh, this is what I did. This is 30. It comes up incorrectly. Let's see. See if I can recall this method. It's 636.6. That's the same. 30. Right, I need to look up my notes on this one. Let's see if the middle one is correct. Nope. So let me see what I did wrong about this method. So, mm, well, as far as I can tell, I did it the same way. Add my 3 times the first row and add it to my 1 times the next row. Copy numbers down incorrectly. Must have just copied some numbers down incorrectly. All right, let's see. Take a look and see what rows I must have copied incorrectly or something. It looks like the methodology is generally right. Oh, I see. At least I think I see. I need to do successive rows. So I was close on my idea, but not right. So I need to do the first number times 161, but then it's the second number times 621. Then it's the third number times 125. So I need to alternate. Oh, that's 152. Okay. And then we have 261 plus 7621 plus 8. 152. So what I definitely have to do is on the exam, just start with the dot product way the way I normally do it. And then if we have to do it a different way, make sure that I check it with the dot product way, since I can do that way better. But clearly what the issue is, we have to cycle through each of the different rows as we go along. So let's see what this does. So just remember that we're basically first column, the first column row number all the way down. So we have 536 plus 36, 12, 6 plus 428, 161 plus 48, 16, 8 plus 6, 30, 12. And we have 2, 12, 2 plus 36, 14, 7 plus 8, 40, 16. So then we have 41. So that should be 43. So, oh, then I have my 4 over there. 40. Right, see what I did wrong here. Oh, this is officially my least favorite way. Oh, copied a one wrong, a number wrong. Right, so often when I'm trying to learn something new, I make a mistake and mix up something. Right, so now let's see what we get. We have nope, still not adding correctly. I hate this method. Hopefully we don't have to do it on the exam. This is my matrix. 564, 186, 278, 161, 125, 812. I have 5, 118, 6, 621, 4, 152. I'm getting 45 instead of 43. Right. Well, let's check the other row. See what happens. But this one I have 45, 37, 54, 49, oh, 54, 47. Hmm. Hate the fact that this method isn't working. Maybe it only works with certain, or it should work with any one that fits. I'm just going to try again and make sure I didn't copy anything wrong or something. I'll just do just the first row. Still getting 45. All right, let's take a look at this. And now see what is going on with this most hated method. Right? Only it is this. Seems it's best to think about it this way. And then 6, 8, 7. And then 4, 6, 8. So let's see what this ends up being. These are all added. And I still get 45. Must be multiplying something wrong and just missing it. I'm just going to move past this method. Let's lose some points on this particular method if I can't get it this time. Oh my gosh. I see the error I'm making. I'm mixing it up with the column way. I'm actually doing the columns instead of the rows. Actually, I didn't change my coloring. So guarantee I won't forget this on the exam now. This is the way it's going. Rows of B. Have it written there, but I was still thinking columns. Hopefully it doesn't give us different problems for the different types of or methods of doing it. I'm going to be in trouble. Like if I have to solve one matrix one way and another matrix a different way, I think I might have to do them all dot product and then work out whatever the method is for that particular problem. So this is the proper format, right? So now let's see what we get. We have 535 plus 6, 12, 30 plus 48, 4, 12, and 161 plus 8, 16, 40 plus 48, 6, 12, and 2, 12, 2 plus 7, 14, 35 plus 64, 8, 16. The numbers do seem familiar. So now I have 32. Let's look at the line below that. All right, now we're in business. 43, 48, 47. That should be 43. So I did another math mistake there. Oh, how did I get 12 out of that? I was looking at the second line. I did the same thing on that part. And then we have 57, 28, 53, and then 73, 30, 53, 34, Looks like that's it. 43, 46, 43. Oh, well, I have 48 there. Do wrong here. All right, so there's some math mistakes on that one. 43, 46, 43, 57, 28, 53, 73, 34, 53. All right, and there's one more method, the compression method, which I probably remember least of all. So let me try to remember what this method is. So this is basically, instead of a dot product, you sort of scale the rows. So I must have called it distribution. Right? So compression, distribution, well, I'm scaling the rows. And this time let me delete my coloration. So I want to take this row and I'm going to scale it with this row. And I'm going to take, this column, I'm going to scale it with this one. And I'm going to take this column and scale it with this row. I'm going to add these all together. So I would have 5, 35, 161, 2, 12, 2, plus 6, 12, 30, 8, 16, 40, 7, 14, 35, plus 32, 4, 8, 48, 6, 12, 64, 8, 16, and the numbers do seem familiar. So we have 43, 46, 43, method easier than the last one. 57, 28, 53, 73, 34, 53. So that's a much easier method. I think I'm just not used to thinking about it in the previous way. All right, so I'll go ahead and take a break. And then after break, I shall be back to continue the review for my exam today. So I have about, 4 hours before the exam. Hopefully I can have time to get something to eat. Might still just take a break anyway, get something to eat. Maybe I'll look at my most pressing type problems and focus on those and see if I could actually get something to eat before the exam. So, all right, I'll be back in a bit.